Hi. So, do you guys want me to drive the meeting, or is there
I think
particular topics?
yeah. So yours is the only agenda on topic on the agenda.
Okay, sure. All right. So, I guess this is a follow-up to one API review session that we've already had, and I think we had some leftover discussion that's spilled over into this meeting. So just to bring people up to speed with what we're talking about here, it's the Istio installer operator API, and this item has been in review for a while. There's a design doc. There's an API that we've had some cycles of review, and I think that for the most part we have some kind of proposal that's had a little bit of iteration. I'm not sure if folks actually have access to that document. I mean, I can certainly present if that's helpful.
Yeah, I think it's really great if you can present your screen as you did the last time.
Sure. Okay, just give me a second.
And I can take some notes.
Yep. Okay. For some reason, I can't seem to present Goland. Oh, here we are. Okay. Okay, here we go. Okay, can you all see that? Can you guys see that?
Yeah.
Okay, great. Okay, so the main idea is to divide up the installer proto more along the lines of features rather than components. So what we have is there's a top level installer spec proto, and we have some kind of global items that are along the lines of the global parts of values.yaml. So this is kind of taking values.yaml as a starting point, and partly refactoring some of those things, but also trying to offer the same configurability as values.yaml in a more structured format. So the first top level items are kind of feature based, and we have basically traffic management config, policy and telemetry, security, and config management. So this is roughly corresponding to the features that are grouped under pilot, mixer, security, and galley right now. And then we have some structured repeated configurations for ingress and egress gateways. And finally, we have some configuration items for external operators. So the other thing that we'd like to do with the install operator is to move out the existing add-ons. So things like Prometheus, Grafana, Kiali, those type of add-ons. This repeated field provides a way to reference those add-ons as operators themselves. It's a general way of referencing items that would be installed through their own operators. And on top of that, we also have some defaults. So those are Kubernetes resources, pod disruption budget, and some other basically defaults that in the absence of supplying per feature or per component values, these would be the default values that would apply. And then there are some other items like node affinity and node selector that also are defaults. So moving along to, we also have a remote cluster config. So this is more of a placeholder right now. It's not really very clear exactly what config features are going to be required here. And this is more of a whatever comes out of the existing work that's going on in multi-cluster. We're going to be compatible with that. So I think this is what we know so far, and that's what I've put in here as a placeholder. And as that work continues, we're going to update this particular config item. So moving on to traffic management config, we basically have and I've just noticed that I think, okay, right. Yeah, so this is mostly taking values.yaml as a starting point. So we have some items for trace sampling, SDS, and then there are items that actually trickle down to the Envoy configuration, like include, exclude IP ranges and ports, cluster domains, DNS search namespace, and a couple of items that right now I'm not sure if this is really the right place to put it, because it's sidecar injector specific config, but at the same time it feels to me like a feature configuration item rather than a component configuration item. So that's the reason that right now I've put them in the feature. But there is also a specific sidecar injector config. And the way I've partitioned feature versus feature versus component is anything that must be a component. In other words, things that really only make sense when you refer to a component like pilot or galley or certificate manager. I've put those items in the component config, and everything else that doesn't necessarily refer to component, I've put into the feature. So that's the criteria that I use to sort all the configuration items. And I think this is open, obviously, to discussion. If people feel that some things are more appropriate in the component, I think it's fairly straightforward to move from place to place. But
So
that's a starting point.
So there are certain fields like the IP ranges, for example. That seems like things, correct me if I'm wrong, things that affect how we generate configuration, right? Rather than whether we enable a feature and like high-level aspects of a feature, or like configuration of particular components, like deployment-wise. But they are more like, how do we create configuration, like data plane configuration, which to me says these probably needs to be captured as configuration objects rather than like an actual CID like configuration instead of installer configuration.
Yeah, I think that's a fair point. This is something that came up in the first API review that I think there's some overlap between what is really installation feature or installation component versus things that are more related to data plane like this. And the only thing is that we don't currently have a mechanism to express these items as data plane components. So because this is something that the mechanism for actually configuring these items is as configuration that gets passed to the injected proxy. So for example, these 4 items are actually flags that Envoy starts with when it's injected as a sidecar. So I agree that from a conceptual standpoint, I think these things feel more like user data plane configuration items, but the mechanism that we have, the only mechanism that we currently have, is all these things actually go into a config map that's passed to sidecar injector, and that ends up in the pod spec that's generated when we inject the sidecar. So that's the reason why it's here.
The split seems to be around whether the config can change dynamically or requires a component restart. If it requires a component restart of some form, then it's in here. Otherwise, it's elsewhere.
I think that not all configuration items require a component restart.
So how is the operator going to communicate that then to the components?
So some items I think are config map. Most of them do require restart. I think there are a couple of items in here that don't require. So that's really why I wouldn't say that's the criteria for items that are in here versus elsewhere. I think there are some things in here that don't require a restart,
But in general, we want to get rid of the config map, right? Use CRDs when possible, or everywhere.
Well, I think that yes, we do. I'm not sure that's something that's part of the install operator work necessarily.
Well, I just worry about as you get rid of the config map over time, these things will become CRDs, and now we have a kind of a conflict between the CRDs of the feature CRDs and this one.
Right. So I think like an interesting question is what is the evolution path, right? So I mean, if you try to couple the work of like weeding out things that needs to be CRDs here and making sure that this is as clean as possible, like installation oriented, that also requires the additional work of plumbing it through additional configuration means, right? Versus we can say, look, this is a scoped work that just targets what we have today in terms of values.yaml, and then we will keep improving the system after this lens. This is just essentially a structural transformation of the installer per se, right? But then it requires the kind of being able to answer, okay, how do we actually evolve this? Like, in the future, when we need to move these settings to CRDs, what's the migration path? Does that make sense?
Yes, but I'm not. So I'm not sure that's something that is. Whether this actually ends up in a CRD or a config map, I think is somewhat. I think is somewhat orthogonal to the installer itself. I think that I mean this is something that we can gradually iterate on, I would say.
Well, that's the thing. I don't think it is orthogonal. If we
Okay.
just leave things as is and you move forward, then as some of these items move from config map to CRD, now the user has two different CRDs that can be affected to change the same feature. So that doesn't seem like a good outcome.
So I think so. Can you give an example of what sort of config items you're thinking of?
Well, so anything
end up
that's in the
being
config map today
Mhm.
would eventually move to a CRD.
So, okay, I think let's be clear here, right? So there is, I think, two levels of configuration where you need to be able to tell, for example, pilot, here's the MCP sources to talk to, right? That requires a restart of pilots or like a major teardown of pilot internals at the very least. That I think might be a good target for this, right? That's actually part of like, how the deployments, like that's the deployment topology, right? So it's the perfect target for this kind of configuration. Whereas there's cluster domain, which or like other settings which are more like, or some other mesh config settings that actually go directly into how we generate the runtime configuration, the data plane configuration, right? So those will be the ones that definitely needs to move out of the config maps, right? So does that distinction make sense?
So I think that if I understand what you're saying, there are some items that we would want to have be we would want to be dynamic through a CRD. But to me, I think so. I'm not sure it's really a given that we would want to move all items that are currently in a config map into a CRD. It seems only things that we would want to have directly accessible by the user, we would move into a CRD. So for example, I think these items like the IP range stuff, I think it makes sense to move into a CRD if we want to allow the user to dynamically change these things. And one way we could manage that is to deprecate these items out of the installer CRD into other CRDs.
Right. So,
but yep.
So we need a procedure and a principle for that, right? So I think that's the thing. I don't think Martin is asking, but is that? But that's what I'm kind of curious about. Where let's assume that include IP ranges is something that we want to be able to provide. Okay, we want to transfer it over MCP, right? As some configuration into the system now. So it needs to be defined as some CRD somewhere. Great. So I actually write all that code. That works, but you still also have this. So what is the migration story from this model to that model, right? So now is there like an upgrade model that we need to take into account, right? Do we deprecate this immediately, or like just say this becomes the default now when you do the first installation, but after that, you are free to edit it, right? Is that?
I think that's one possibility, although just for the sake of consistency, I would probably lean towards just moving these items out altogether into those CRDs and not have the duplication. And I think most of the items that are in this CRD currently fall into the what you would think of as the static configuration. In other words, things that require restart. If you look over the CRD, there's probably, I would say, maybe 80% of the items are things that probably clearly fall into the camp of requiring a restart, a component restart right now.
Okay, so the upgrade path then, if we move these things out, would effectively be when you install the new version of Istio that has the stuff as CRDs, you need to run a batch file or something to go and clean up this CRD to remove these extra fields.
Pretty much, yes.
Okay, so that I think that's a reasonable story.
Yeah, I mean, I think unless work happens in the near term that makes that possible, and I'm not sure of what other work is going on in parallel to enable that. But if some work is being done that aligns with the timeline of when the install operator becomes available, we can move those items right away. So
Yeah, I don't think
anything
anything's happening in this space at the moment.
yeah. So I think, luckily I think that most of the items that are here are not things that fall into the sort of dynamic configuration category. I think most are going to be, sort of static, require component restart type of things. And so I don't think that there's going to be a ton of things that we would need to deprecate and migrate. But yeah, there may be some things. Okay. So just moving along to the other feature, sort of feature categories. I've combined policy and telemetry together. I'm not sure if that's the right move, but that seemed to be what people were voting for. So I've these two together, and also security. There's some kind of like feature level things in here, and in addition, I've also grouped the components.
Martin, I think might be muted.
I didn't have anything to say.
Oh,
These things are obviously optional, and I would expect that most users would stop at the feature level settings, and they wouldn't dive down into the component level settings, because most of the component level settings relate to things like Kubernetes stuff. And I think many users are probably just going to stick with the defaults that we provide. But we have to offer some configurability there. So let's see. So we have some component level configs. For example, we have pilot, and actually, what's interesting is I've changed some of this stuff. So this is a little bit out of date, but it doesn't look like I've updated this particular proto. Let me just see if I can quickly pull up where I have the latest changes. Yeah, let me just share this one really quickly. Okay. So in here, traffic management, policy telemetry, security, pilot components. Okay, interesting. Anyway, so this is a little bit different, but basically it's this very similar. The only thing that I've changed is that there is now a common component configuration. So things like enabled, namespace, debug, and then all Kubernetes related settings have moved into a common component config. So for things like related to pilot, sidecar injector, and the policy telemetry components and the security components, all those actually have a common component config. So there you can specify things like replicas, HPA settings, pod disruption budget, node selector, these kind of basically things that relate to actual components rather than features that can span potentially multiple components. And then the other thing that's common to components is a customized style overlay. So this is where if the level of customization that's provided in the component config is not sufficient, you can go one step further and override Kubernetes resources using this overlay. So you can directly refer to services, deployments, basically all Kubernetes resources, and use customized style overlays to make any changes at that level. And this is something that is there to, first of all, remove some of the settings that we currently have in values.yaml that are very, very specific to just a particular Kubernetes component. And secondly is to give users a way to basically express configuration in a way that survives upgrades that doesn't require editing templates.
So is this basically so I can add labels to things effectively?
Yes, that is one thing that you could do here. And actually, I don't have a label setting in the component config right now, but that's something that we could add potentially.
Well, so what? Give me an example of what I can do with this customize thing.
So the way this would work is once you've specified the CR, the install CR, the operator would actually render a set of manifests out of this, and those set of manifests would specify things like deployments, for example. So what this would allow you to override is anything that's in those rendered manifests.
Okay.
So post whatever values are specified in here, you can override
the things that
the
are
generated manifests. Yeah. So this is kind of a backdoor, and I don't think this is something that a lot of users will reach for, but at the same time, it's a necessary backdoor that we need to just give folks a way to override things in a way that's going to survive upgrade.
Yeah, and this is a very common approach in the community as well, using customize as a way to provide that level of override. And I agree, this is our best option as far as a backdoor to be able to override just about anything.
Yeah. Okay, let me just switch back to Golang. I think that's a little bit more convenient to look at. Okay. All right, so we have pilot, proxy, sidecar, and then we have basically the policy and telemetry components. We have, oh yeah, I did actually put, I do have a common component config in here. I'm just not really sure why. Oh, I see, okay. Yeah, it just seems like I didn't put enabled in the common component. I didn't remove the enabled fields in sidecar and pilot and proxy. But yeah, that's basically, I just didn't update that. But there is a common component config. And as I mentioned, the sort of things that we have in here are whether the component is enabled, the namespace that it goes into, if it's not the default top-level namespace, hub and tag, environment variable settings, Kubernetes stuff, pod annotations, node selector. and resource overrides. So there's also settings for ingress and egress gateways, and there's a load balancing gateway config, which really doesn't have a lot, but that's basically what we have right now, available through values.yaml.
Sorry, I have a very stupid question. Should we actually have hub and tag here? So here's my rationale in asking this question. I see this kind of our configuration into the system, saying that I want to I want you to go ahead and deploy Istio, right? And that itself is probably against an operator that is targeting a particular version of Istio. And things like hub and tag actually are part of either that release cycle. There's one standard place where we can pull things in from, right? Or it can be used for development purposes, but in either case, it almost feels like the configuration for the operator itself, right? I mean, it might be a subtle distinction, but I'm just curious whether people have thought about this.
So my answer to that is the way that I've seen hub and tag being used is mostly for debugging. There are some cases where folks have used those fields to supply their own image of Envoy, for example.
Mm-hmm.
But in most cases, it's just used for debugging, for pointing to a custom pilot, for example, for debugging. But it's I don't think this is something that would be commonly set. In which case, you would just use the top level hub and tag setting in the base message.
Right. I'm kind of going one step beyond this, right? So essentially, as a developer, I have much more latitude in changing the system when I'm developing Istio itself, right? I can actually make configuration against the operator itself, and as part of my operator deployment, I can say, don't use the official Istio repository, use my local one for everything, for example, right? Which for development purposes is perfect, but when you go to a real deployment, do you actually want to expose these values as public APIs? And I think that's one of the concerns that I have in general, where, okay, we are actually getting our values YAML and creating this thing, but at the same time we are creating a public API in which we have these tags, and I'm not sure whether it's the right thing to do or not. I truly am not.
So the operator does provide a mechanism to point to an installation bundle, if you will, which by default is the local path. So that's what's going to be compiled into the operator. But you can also point to a custom bundle, for example, that specifies a custom set of charts and a custom values.yaml. That functionality is there in the top level installer spec. So we have this install package path.
Right.
But as far as hub and tag, yeah.
Okay, but so quick question: is this does this mean the installer is going to work beyond, for multiple Istio versions? Right? Is it designed? It's clearly not designed that way, because most of these settings are very version specific, right? So we expect these things to change from version to version. So at best, you can only support Istio versions up to a point and below. And to me, that says the operator itself needs to be version aware, like Istio version aware, and when you are building the operator, or when you are actually creating a configuration for the operator itself, that's when you need to specify these things, but not as the public API of the operator itself.
Right. So yes, the operator is tied to a version. That's the current plan, and the reason is primarily just to constrain the the amount of testing that we have to do. Actually having the operator support multiple versions makes just the testing story a lot more complex, is one thing, and actually the maintainability of it becomes quite a bit harder as well. So the current plan is to have a version of the operator for a version of Istio.
Mm-hmm.
Yeah.
Right. So based on this, hub and tag essentially are really there for development purposes, right?
Yeah, I mean, I think that the hub and tag are really just primarily for testing. I'm not sure what other avenue we would have to conveniently expose those. I mean, we can certainly remove them from the public API. I think that that's probably going to make things a bit inconvenient for folks. One possibility is to actually move that into the customized overlay. That would make it a little less exposed, but it, at the end of the day, if you have the customized overlay, people can change anything they want, including hub and tag, because they can reach in and into a deployment and change the image path. It's just a matter of
level, the right hurdle. We don't want customers to be using this. Let's not put it in the main API. Expert use cases can do the expert thing.
Right. So, for example, when I am deploying the operator itself, which is going to be a deployment, right? I can specify the hub and tag as, say, environment variables, and that says, look, don't use the default one, use these ones. And I can change, as the developer, I can change the deployment of the operator, and then the rest dovetails out of that, for example.
Yeah, I think that makes sense. Sure. Yeah, I can move this out.
Could you go back to line 475?
475. Okay.
Let me see here. 475. Okay, so first, that P, its IP should be lowercase. But I was wondering, in general, there's a lot of IP addresses in this, and would it be worthwhile to have a type called IP address? I don't know where we're going to end up with our CRD validation logic, but having a systematic type, I think, can only help on that front.
Sure. Yeah. Oh, that makes sense.
And I don't know if there's others. There's also line 477 has. Okay, that's the same one.
Yeah, I can go over this and take a pass and make an IP type for that.
And 447 also has an uppercase P.
447, right?
And 443. Okay, it's a common pattern.
Yeah, that's right there.
And I wonder, are there other common strings that have semantics like namespace that we also could use a type for?
I don't think, like, at the proto level, using particular types for these is going to be helpful unless you also make it structured, right? So if it's just going to be a string within a message, I'm not sure how useful that's going to be.
Well, it's just now we know it's an IP. If the type system does not indicate it's an IP address, nothing's ever going to be able to systematically check that it holds an IP address.
So, which presupposes that we will actually be able to come up with a tooling that will look at the types and know how to validate them, which I don't think we have, or I don't think we have an example of it either. So, I mean, if it was a structured message with like multiple byte fields, for example, I can totally see the argument. But if it's just going to be a string, you're just tagging the type, you might as well tag the field.
But with what?
So, using the type of an IP message instead of string, if you're using that, that's in effect tagging the field, right? So so that you can look at the type system, the parsed proto, and tell that it's an IP, right? You can actually put the same information into comments, for example, or into extension options.
Okay, I don't understand what you mean. So when I have string load balancer IP, what would that be?
And then you can have an proto option saying that this is build date is an IP field.
Okay.
So that's the alternative. And there are tools like the proto general date that somewhat supports this.
Okay, because I'm also looking at this from the doc standpoint. When we generate docs for this, it just says load balancer IP is a string. And I'd like it to be something better than just saying a string.
I think at the very least it makes sense to create a type for this, whether it's a string or something else. I think that's optional, but
the problem is proto doesn't have alias types, I believe, right? So you cannot say I'm creating an alias to string, which is IP, and that becomes like a first class type in the system. The only alternative you have is creating a message, which affects your editing. Which means when I'm editing this file, I'll say load balancer IP colon curly value is this, unless I actually try to embed some like custom marshalling similar to how ANIs work, for example, which I believe is a somewhat hard thing to do.
Right. Yeah. 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 I mean, that's really kind of a problem with proto in general. That there are some things that are not easily expressible in proto.
Okay. Well, I guess never mind then.
Yeah. I think this is something that we could create at the struct level. But yeah, I'm not sure what to do with the proto.
Yeah, I think the general convention has been like tagging the fields. Like cell, for example, has a model for saying like the proto validation is like here's an expression to validate this thing, right? Or the proto gen validate has a similar thing. It has an annotation based model. And I think for documentation, you can actually put things in comments. Maybe it's similar to like Java model, which we already have, I believe, right, Martin?
Yeah. The comments will be extracted. So we list just field name, type, and then the comment. So I mean, it's pretty obvious. It's underscore IP. It's an IP address. It kind of makes sense. But I like strong typing. I don't like just having hundreds of strings.
It's, no argument there. It's just
yeah.
This is what we work with.
Okay.
Okay. Yep. I'll follow up on that. I think that's a good point. So, yep. Yeah. So continuing on, the other things that we have are there's kind of a placeholder for external operators, which really just point to a manifest path for that operator and kind of a customized overlay spec. So it's kind of freeform right now. Users can take a default that's specified somewhere, and presumably that's going to be some public repo, which is going to it's going to be a copy of something that's specified publicly as a default installation for an add-on component, and we would have customized style overlays to make edits to that. So that's the current placeholder.
So why is that desirable as opposed to just it's not our problem, it's an unrelated operator, somebody else can install it?
Yeah, that's another that's another way to install it, and having this I think doesn't preclude it. I think for cases like where we would want to in a more compact way install an add-on component as part of the initial operator install. So in managed cases like Istio for GKE, we wouldn't want to bundle sort of lengthy manifests to install those components. Not that we would do that, but if we wanted to install some external add-on, we probably wouldn't want to bundle the entire manifest of that component as part of the installation. We would want to have like a more compact way of expressing that. So that would be the reason. But I think this is optional. It doesn't prevent people from not using this and just directly installing whatever they want. So it's more for managed use cases, I would say.
Okay.
Does it make sense?
Yeah, sounds reasonable.
Okay, so one thing that I wanted to get some feedback on is we've had some discussion about what sort of things we'd like to observe in the operator state. So I think it probably makes sense to have things like just in the installer status. Right now, I just have some strings that just report the status of the features, and it would be something like just ready or healthy or something like that. Would we want to have anything beyond that to sort of get a more structured status? We always have the Kubernetes component status, but my question is, do we want to have something that's a higher level status that perhaps refers to multiple components or other higher level concepts than Kubernetes resource status? Do folks have any opinions on that? Should I just leave it as is for now? Just basically have a running state of the feature and possibly the components?
Well, from a user standpoint, from the standpoint of using this as an API, I think I'd prefer to at least have a Boolean that says yes or no, and then what you have there is the error string, as opposed to having to pattern match that string with the word healthy.
Okay, all right, I can change that. Beyond that, is there any status that at this time you think that users might like to see? Those users including potentially CSM.
So I think you want to have a bit of structure, as I think Martin was saying. Do you think you can come up with a kind of a more structured way of representing this? So one idea is, again, just an idea. You can have a map or repeated list of things here that describes for each component some common things and maybe some extension things. Like, you can say, hey, this thing is active, enabled, or running versus there's some error case, something like that. Would that be useful?
Well, related, I was wondering that when does the status get reported? Is it guaranteed that everything's been deployed and is currently in use? Or is it in the process of being deployed and you don't actually know when everything's in use?
Yeah, so essentially, sorry, go ahead.
No, my initial idea was just to look at deployments, like status of deployments, as a starting point. So for all the components that are in a feature, I would just look at the deployment status and just roll that up into the feature status.
Yeah, I wonder if that's sufficient, because if you think of somebody using this to support their system, like Knative, for example, they want to make changes to potentially a deployment and know that, okay, it's okay, I can send traffic now, which is different than just saying, well, pilot's up, but it's not quite ready yet.
So that's mostly captured in the readiness probes, though, I think, right? So I think we should still be able to observe the deployment and gather most of that information. Okay. What I think might be more interesting is the case of I do an upgrade and like whether my upgrade has completed or things of that nature as well. Right. It's one thing to say the component is up and running. It's another thing to say my upgrade has also completed.
So when you say upgrade has completed, how do you see that proceeding?
So the higher level scenario that I have in mind is I need to create orchestration, right? And by being able to say, look, as soon as this thing deploys, I'm going to do something else. Okay. That's kind of the Knative scenario that we have been hitting so far. And installation is one thing. Like the first time installation, the readiness probes fire, and I think gives you a good enough signal to start pushing configuration into the system. To like Istio configuration. So they actually have like one down level problem with the Istio configuration, but that's a separate thing. The second use case, similar use case, is essentially when I try to do like an upgrade of the system as well, right? So I want to upgrade my system, and I want to be able to say, okay, I want to do an in-place upgrade of Istio, right? And I want to actually take another action as soon as that deployment is done. So I need to be able to kind of somehow write reliable orchestration based on some signal here.
I'm just wondering what that signal would be. I mean, do you have any sort of specific examples of what type of signals?
One strawman example. This is a complete strawman example, right? So you can actually have for each component a field, like structured field that says pilot, right? This is the version, this is the current version, and enable true, right? And then you can actually, or have an enum saying that this is stable or this is active. And when you are doing the first time installation, the enum will not be active, it will be, I don't know, some transitional state where deploying, or it can be upgrading, right? So, and then I can look at that value of that enum and say, oh, like it's in a transitionary state, so I should wait, right? And I can keep looking, and as soon as I see, hey, this is active now I can go ahead and do my next operation.
I see. So how about because this is pretty upgrade specific. If we were to say that a status applies to a particular version, so if there was a version field that was part of the structured status, would that be sufficient? Would that work? So,
yeah, I think that could work.
Okay. Yeah. So
again, this is like I don't have a particular this shape should look like this, right? But I kind of have the scenarios in mind, right? So those are the two scenarios where I do the first upgrade or installation, or I do a rolling upgrade to newer version, and I need to have a reliable signal. Is the case that I'm aware of.
Yeah, I think that makes sense. So let me take a stab at it, and I think that I think actually reporting the version would probably give users enough information to detect situations like where they've triggered an in-place upgrade and they want to know when that upgrade is completed, because in that scenario, they would know the target version that they're looking for. Right. So coming back to where we left off, I think we went through the gateway stuff and the external operators, Istio installer. So this is just the combination of spec and status. And then I have some items that I had to actually copy in here from the Kubernetes protos because of difficulties with unmarshalling everything. So unfortunately, some of the things I could not directly reference in the Kubernetes protos because they have a custom unmarshal, and that it only works if you attempt to unmarshal a top level Kubernetes resource that contains those fields. So I just copied them in here. There's only a few such things. So that's why they're here. And then, so basically the definition of the customized style overlay, it's going to be a patch. Basically, there's different patch types, either strategic or JSON merge, and then you can add, delete, or patch. And then you can specify, basically, this is just going to be a raw field that specifies the key values and or some YAML block that you would override with. And I haven't yet been able to figure out a good way of representing this in the proto. It's something that we would like to appear as a map of interfaces in the Go structs, but I haven't figured out a way to actually convince the proto compiler to generate the structs correctly. There may be some annotation that's available that does that, but right now it's just yeah. But
I kind of missed why you specifically need map of string to interface. I know the map model of the code gen stuff is pretty bad, right? But what stopped you from using that?
So what stopped me was, sorry, you mean in the proto or in the struct?
So if I understand this correctly, the problem is in the Go struct that's being generated, you want to have a map of string to interfaces instead of the standard value-based thing that Proto does, right? So I'm trying to understand why is that, why is that a requirement?
Well, I want to be able to unmarshal into a tree. So this is just something that is going to be a YAML tree, and I want to be able to unmarshal that into a tree structure. And the way to represent that in a Go struct is a map of interfaces, and I'm just not aware of any way that I can convince the proto compiler to actually emit that.
So I don't think you can do that, because in Mixer there was some custom code that tried to do that, and first of all it only worked one way, so you would not be able to unmarshal, for example, right? So you can't go the other way, and the second, it actually caused quite a bit of grief when we tried to do some uniformization in the code, right? Especially in the Istio API repo, so we got rid of that. So I know it's generally a bit the Go model of the generated code is a bit bad, but I think if you put a map of string to struct, for example, here, the Google protocol of struct, then you can, on the code side, come up with a translator that can create map of string to interfaces, I think. Should be fairly straightforward to do that.
I see. I see. Okay. Okay. Yeah, I'll give that a try. Yeah, makes sense. Let's see. So that pretty much is everything. The only other thing is that some of the items that I have in here, the tracer config and some of the adapter configs are going to be in other proto files. So that's some feedback I got from the first API review, and I'm planning to move those out into other proto files. So there shouldn't be anything that's adapter or tracer specific in here.
Yeah, because these do suffer from the problem of the multiple sources of truth, right? The standard I/O adapter config output as JSON is an option in the adapter's CRD.
Right. Yeah. Well, I think that's kind of a underlying values.yaml problem, it seems to me.
Yeah.
I think we could remove that from values.yaml and then it would disappear in here. Currently, I haven't left anything not being able to be referenced in values.yaml. So I haven't actively started removing things that are available through values.yaml. But for things like this, I can certainly do that.
Yeah, I think it's worthwhile. All right. We're quite a bit over time here.
Yeah. Okay. Is there any? Do we need to do another round of just reviews? I think we covered a lot of ground here, right?
Yeah.
Yeah. Okay. Okay. I guess this is
So
rubber stamp.
there is. I'm going to take a stab at just incorporating.
I think you're breaking up.
From this review, and there's going to be a PR, and for anybody who's interested, I can put them on the review of that PR as well.
Okay.
So you can look into the specifics.
Sounds good.
Great.
Great.
Well, thank you very much for the feedback. That's very valuable.
Thank you.
See you later.
All right. Bye.